On the morning of July 1st, 2025, an automated sky survey telescope in Chile picked up something moving through the inner solar system. Fast. Too fast. The object was traveling at a speed that our sun's gravity cannot explain. It wasn't slowing down the way it should. It wasn't behaving like anything born here. Within 48 hours, astronomers had confirmed what many had suspected the moment they ran the numbers. This comet did not come from our solar system. It came from somewhere else entirely. And unlike the two interstellar objects we'd found before, this one was giving them a much longer look. It was bright enough to track, bright enough to study, bright enough to begin asking the question no one had been able to answer in the 8 years since we first discovered objects like this exist. Where does something like this come from? The comet was designated 3OI/8less. The 3 stands for third, as in the third interstellar object ever detected by humanity. The I stands for interstellar. Atlas is the telescope system that first spotted it, part of a global network designed to catch asteroids that might threaten Earth. On the morning it was found, it wasn't threatening anything. It was just passing through, as it apparently has been for a very long time. The Discovery team ran the trajectory backwards through every simulation they had. They checked for gravitational influences. They modeled the slingshot effects of every major body in the solar system. And when they were done, the math pointed to the same answer every time. 3I/Atlas entered the solar system from interstellar space. Its path cannot be traced back to any known origin in our cosmic neighborhood. It came from the direction of the constellation Draco, but past that, the trail goes cold. To understand why that is extraordinary, you need to understand what the solar system is. Our sun formed about 4.6 billion years ago from a collapsing cloud of gas and dust. Everything in the solar system, every planet, every asteroid, every comet in the Oort cloud, formed from the same cloud at roughly the same time. They are made of the same raw material. They carry the chemical signature of this specific corner of this specific galaxy at this specific moment in cosmic history. 3I/Atlas was not formed here. The spectroscopic analysis confirmed it carries a different chemical composition than any object we've cataloged from our own solar system. It formed somewhere else at some other time from some other raw material. In the preliminary dating of that formation, based on the abundances of heavy elements and the state of its volatile compounds, puts its origin at approximately 11 billion years ago. Our sun is 4.6 billion years old. The Earth is 4.5 billion years old. Whatever cloud of gas and dust produced 3I/Atlas did so 6.5 billion years before any of this existed. Here is where the story becomes impossible to think about. 3I/Atlas is not just old. It has been traveling for a very long time. Interstellar comets don't sit still. They move through the galaxy at tens of kilometers per second, following trajectories shaped by encounters with stars, molecular clouds, and the gravitational pull of the galactic disk. To produce the trajectory 3I/Atlas currently has, it had to have been moving for billions of years since it was ejected from whatever system created it. Which means, for the majority of the age of the universe, this object has been flying through the void between stars in complete darkness, in temperatures close to absolute zero, carrying whatever chemistry it was built with from a star that has almost certainly burned out and died. It is, in the most literal sense possible, a messenger from a world that no longer exists. The second extraordinary thing is how it got here. Objects like 3I/Atlas don't just wander into solar systems at random. The math of gravitational dynamics suggests that for an interstellar object to pass through the inner solar system, close enough for us to detect it, it has to be aimed with extraordinary precision or extraordinary luck. Or there have to be so many of these objects flying through the galaxy that even a near zero probability becomes inevitable over enough time. Astronomers currently believe the third answer is correct. The galaxy, by this model, is full of these things, ejected remnants of planetary system formation, comet-like objects flung out when young solar systems stabilized around their stars and evicted everything that didn't fit. If the estimates are right, there may be more interstellar objects passing through our solar system at any given moment than there are natural objects orbiting the sun in the Oort cloud. We are swimming in the debris of other worlds, and we only just started to notice. The first interstellar visitor we ever confirmed was Oumuamua in 2017. It was already leaving by the time we spotted it, and it behaved strangely. It accelerated as it moved away from the sun in a way that could not be explained by gravity alone. Various explanations were proposed, none fully satisfied. The second was Comet 2 I/Borisov in 2019. It looked more familiar, a standard comet with a coma and a tail, and gave astronomers a longer window to study. But 3I/Atlas is different from both. It is larger, it is brighter. Its trajectory through the inner solar system is slower relative to the previous two, which gives observatories more time to point at it. And its arrival coincides with a new generation of sky survey systems capable of capturing data that simply didn't exist in 2017. For the first time since we discovered that interstellar objects exist, we have one that we can actually study. What astronomers have already learned from the early spectroscopic data is this. 3I/Atlas contains carbon compounds in proportions not commonly seen in our own cometary population. It contains water ice as expected, but the ratio of certain isotopes is different from what you'd find in a comet from the Oort cloud. Its surface has a reddish tinge, which is consistent with organic material that has been processed by cosmic radiation over billions of years of exposure in interstellar space. None of these individual facts are conclusive, but together they paint a picture of an object that had a genuinely different origin, a genuinely different chemical history, and a genuinely different 11 billion year journey before it arrived in our neighborhood. And somewhere in that chemistry, locked into the ice and rock of an object from another star, may be information about how chemistry works in other parts of the universe, whether the same molecular building blocks show up everywhere, whether the universe is, in some sense, chemically consistent, or whether what we see here is local, whether life, if it exists elsewhere, has to work with the same ingredients. No one has said that yet in any official scientific paper, but the question is being asked in the hallways. When 3I/Atlas eventually leaves the solar system, and it will because nothing is holding it here, it will continue outward into the void for another several billion years. It will pass near other stars. It will carry whatever it carries into the next solar system it encounters, and the one after that. It is not going home because home no longer exists. The star that created it burned out billions of years ago. The planetary system that ejected it is gone. Even the molecular cloud that collapsed to form that star has long since dispersed back into the galaxy. The only thing left from that entire system is this object, still moving, still carrying the chemistry of a vanished world, still doing what it has always done, traveling. In the silence between stars, in the dark between galaxies, in the vast, unmeasured distance that separates one moment in the universe's history from another. We caught it for a few months in the summer and autumn of 2025. We pointed our best instruments at it. We asked our questions, and when it left, it took most of the answers with it. We know where it's going. We still don't know where it came from.